Okay, I've got quite a lot of content. I'll try to get through all of it without speeding too much. I'm pretty happy about questions generally, so let's see how we do. A very few facts about myself. Most important one, maybe if you want to talk to me, contact me. You can find me on Twitter as Henry Klein. And if you have other facts that some of you may or may not already know. Anyway, we're here to talk about browser performance. And browser performance, in a way, how does a browser actually consume resources on your machines? And by significant resources, not just a little bit. Browsers are not simple applications anymore. Browsers are basically operating systems for web apps. And any typical browser, count the tabs you have open at any given time. I guess it's at least 10. Some people have 50 or 100 tabs open. And each single tab is a web app. And obviously, apps consume performance. They require resources to run. And that is a very significant topic you need to be aware of. And that with this session, I'd like to raise awareness of that, of this entire thing. So let's start with this. Here, you can see me typing. Well, you can't see me, but you can see the result of myself typing in a Mac OS 7 machine. So I did go to a lot of trouble to locate a machine, maybe even buy it, stuff like that, didn't I? Well, obviously not. It took me a couple of minutes to search a virtual virtual Mac OS 7 instance running in my browser emulated in JavaScript. I didn't have to do anything. I just had to open that page and Mac OS was starting to boot. So that's what's possible in a browser today. Obviously, emulating an entire computer, including the OS, in software and in an interpreted language like JavaScript will need a little bit of performance. So not only Mac OS, you can run Windows 95 in your browser. Just, you can see the URL, or Google will find it very easily. Or also games like this. Who played this when they were younger? There's at least one, yeah, Ruben. And some that was for the Apple II. There's something a little bit newer, Command and Conquer. And one thing you may find interesting, the actual resolution is just this of the game. So computers have evolved quite a bit. That is just the web page hosting the emulator. Okay. So those are just a few examples to get us started. So the main areas how websites do consume resources on our machines is, one is JavaScript. We sort of examples of that. These days, people do totally crazy stuff in JavaScript, like emulating Windows 95 and so forth. The second one is video playback. Everybody plays back video. YouTube, I don't know the numbers, but YouTube has billions of hours watched per second probably. Then there's all kinds of graphics. WebGL is kind of interesting. It allows direct access to the GPU. And then there are ads, which kind of tend to suck the performance out of the machine faster. You can blink. And ads, of course, use any kinds of technologies. They play videos and whatever just to try to get your attention. So in this talk, we're looking at video playback, JavaScript performance, and the impact of ad blocking. Now, video playback. When we're talking about video, especially video in the web, we need to understand a very important concept. There are video containers and there are video codecs. Containers are the most popular ones, or the relevant ones on the internet are MP4 and WebM. MP4, the big difference is MP4 uses codecs that are not royalty-free, and WebM was initiated, or at least Google promoted it quite a bit because they don't like paying royalties to other companies. Let's take a very quick look at browser support. So the most popular one is the MP4 container format, which is MPEG-4. and with the H.264 codec for video and AAC or MP3 for audio. This page is quite nice. It's with this URL, this site, sorry. It's called caniuse.com, and you can look up the compatibility of various modern web techniques or technologies, rather, with all kinds of browsers, and you can even go back and see when which browser version first supported a certain technology. So everything's green. Basically any browser supports H.264. That's the default. Then H.264 has a successor. It's called H.265. It's a lot more efficient. Basically, for the same video quality, it just needs half the bandwidth or half the video file size, however you want to put it. Support for that is actually basically non-existent in browsers. Only Edge can play H.265 encoded videos, and only if if Edge can upload the decoding to something installed in the machine, to some GPU with the drivers. So Edge does not natively play H.265. Now, why don't browsers support H.265? Apparently licensing costs are very high, and nobody likes to pay royalties to other companies, of course. Now, the second important container format in addition to MP4 is WebM. And you can see here that basically two browsers support WebM. That's Firefox and Chrome, and as of pretty recently, Edge. Now, being able to play back a video is one thing. Being able to play it back efficiently is a very different kind of matter. So we want to offload the decoding of the video to the GPU. In order for that to work, many things have to be just right. So you need obviously some kind of hardware that can do the actual decoding. Then you need the driver that exposes the GPU's capabilities to the OS and to applications. Then you need to have an application that actually makes use of those capabilities. And then finally, it all depends on the video properties, so the codecs being used. GPUs, their hardware is finalized. You can't the decoder, even you can program GPUs, you can't program the video decoder. So what a certain GPU can decode depends on what has been baked in when it was created. So it even changes with resolution. So some GPU might be able to decode full HD, but not 4K. Or what's currently pretty trending is HDR, so enhanced color space support. That's another thing that the GPU needs to be able to support in hardware. A very nice little tool if you want to actually check what is available on a specific machine, given the drivers, the GPU, and so on, is DXVA checker. It's a free little tool. Here you can see a screenshot of it. And it basically shows you the capabilities exposed via Microsoft's DirectX Video Acceleration API. And that is the API that is being used by applications to access hardware, the decoding capabilities of the underlying hardware. And well, the output can be a little bit cryptic, but yeah, looking at it long and hard, you finally realize what might be what. An important thing to note is that there are various names for the various codecs. So for example, I mentioned H.265. It also goes by HEVC, sorry, I can't remember right now. Or, well, H.264, interestingly, is called just that. Although sometimes it's called ABC, whatever. So, a little bit of information on the various codecs and where they can be accelerated and decoded in hardware. So we saw that H.264 is the codec that is most popular, that is basically supported anywhere in any browser. And it can also be accelerated, hardware accelerated, basically on any device, on any GPU that has been sold in the past 4 years or so. But if you look at 4K, so if you want to play 4K videos and have them hardware accelerated, you need a little bit newer card. Now, where is H.264 used? On which video websites like YouTube and so on? Now, basically, every video you play on the web is encoded in H.264, except when you go to YouTube with Firefox or Chrome. YouTube detects the browser, and if it detects that you're using a browser that can hardware, that supports WebM, with a VP9 codec, and probably can also offload decoding to the hardware, it presents that to your machine. Now, H.265, it is more modern, it is more efficient, so why not use it? Well, I mentioned earlier, browsers don't like to support this, and because the browser vendors don't want to pay royalties to the patent holders. So it is not used by any video website at all. Obviously, you want your videos to be consumed as a video website owner, and so the first thing, they need to be able to play back. Well, hardware acceleration of H.265, independent of browser, just what your hardware can do, is only available in pretty new GPU models. So Intel, the second latest model, Skylake and up, so Skylake and Kaby Lake. NVIDIA Maxwell and AMD FG Polaris and so on. Now, the third important codec here is VP9, which is used with the WebM format. Remember, that is what YouTube gives you when you take Chrome and play video, any video on YouTube. Well, hardware acceleration is only available on the latest generation of Intel CPUs, GPUs, and also on very new models of NVIDIA and AMD devices. So if you run Chrome, for example, on a little bit older machine, the video will be decoded in software, and that is, of course, less efficient overall than having it be offloaded to the GPU. Okay, now we saw that little tool, DXVA checker, so that tells you what your machine can do. Another thing is, well, what does the browser actually use? Of course, it depends on the browser version and so on. In Chrome, there's a very nice way to check what acceleration capabilities of the machine are actually being employed. You can open that by just typing Chrome //GPU into that omnibar, and then you'll get something like this. You'll get a lot more information. It's multiple pages, but the interesting stuff for video decoding is here. Video decode, hardware accelerated, means it can play back H.264, and VPX stands for VP8, VP9. Those are the codecs used on YouTube, and in this case here, they are also hardware accelerated because I made all the tests on this machine. It has a Kaby Lake CPU, so it's basically the newest of the newest, and so that hardware acceleration support is available. Now, how can we measure? For the following tests, I used, this machine with the latest of the latest, basically, the Intel Windows 10 Creators Update, Kaby Lake CPU, as I said, and I tested the 4 relevant browsers on Windows, and the latest versions available as of 2 or 3 weeks ago. You can see them here: Chrome 58, Firefox 53, and Edge in NIE, what was available in the OS, which was, of course, fully patched as of early May. Now, what I did for these video playback tests, I tested 4 different sites to get a little bit of diversity. YouTube and Dailymotion are the most popular out there, and Vimeo and Wistia are targeting business customers. And they played back 4 different videos, one video on each, 4 different ones in total. I basically chose them randomly, but I made sure that all were available and played back in full HD, so 1080p resolution. So theoretically, we're always we always have the same workload. And let's see how that same workload affects what that looks like from a performance point of view on this machine. There are a few challenges to measuring performance. One of them is that browsers these days typically use a multi-process architecture. Chrome started that, and Firefox, Internet Explorer followed, I think, and these days even Firefox uses multiple processes, though not as many as Chrome. So what you need to do is when you want to look at the browser's performance, you need to, in the case of Chrome, you need to look at all those chrome.exe processes and add up their performance numbers. Or when you're looking at Edge, it has one main process called Microsoft Edge.exe and multiple content processes called Microsoft Edge CP.exe. And when there's DRM involved, so for example, when you're playing Netflix videos, there is an additional content or process for that. In the case of Firefox, we have multiple Firefox.exe processes and one plug-in container for DRM content, if you're using that. DRM, just for the interest, putting that here to be to give the complete picture. When you're playing back videos from those 4 sites I mentioned, they are not DRM protected, so that doesn't apply here. And in Internet Explorer, yeah, that's basically the same applies. 2 little tools that may be of interest. IE11 has this little, what they call performance dashboard, this little thing. And you can bring it up by pressing Ctrl-Shift-U. And if you do, it will show this little thing in every tab, so you can look at frame rate, memory, and CPU consumptions, which can be quite useful. I'm just going back one slide, I forgot to mention that Chrome has a much more useful tool, the Chrome's Task Manager, which comes up when you press Shift Escape, and it gives you a lot of detail into what is going on in those various tabs. Okay. What I did, I used our company's product, UberAgent, pretty powerful monitoring and analytics product for all the measurements. So all the data was collected by UberAgent. And basically, on the machine there was the Uber agent, stupid word, with the actual agent which collected all the data. The data was being sent to the Splunk backend where we have dashboards and stuff and can easily analyze what was going on. Now, what kind of metrics did I look at? So I looked at some of the obvious ones like CPU, RAM utilization and disk utilization in terms of IOPS. But I also looked at, well, we're interested in the hardware acceleration part too. So that happens on the GPU. So we need to look at what's going on with the GPU. UberAgent measures that too. And here's just the GPU metrics. I wanted it then formatted in a specific way. So I used this search command in Splunk. And the other metrics I just looked at one of UberAgent's dashboards and just picked them from there. Now, let's take a look at the first results. So, first let's analyze the video playback efficiency by browser. So, as I mentioned, here are the various metrics. CPU utilization in percent. RAM usage of the entire browser application, so all the browser's processes combined in megabytes, disk IOPS, and then GPU compute utilization, so how much is it computing to get that stuff going, and GPU memory utilization. And there are quite a few interesting findings here. One is, of course, well, these are the averages of all 4 video sites. A little bit later on, I'll show you differences between the video sites, which is also pretty interesting. But clearly, the most efficient browser is good old IE. Who would have thought that? Look, the CPU utilization is pretty much the lowest. RAM utilization is very low, basically no disk I/O. And GPU usage is also very, very low. So that's great. So just keep your users in IE and you can maybe throw away the cells. Clearly the most inefficient is Firefox. Look at the CPU utilization. RAM utilization is a little bit better than than Edge, but not better than Chrome. And GPU utilization is pretty, or the GPU implementation is quite inefficient. And that is all for the same workload. So all the browsers are doing exactly the same thing. And one interesting thing, Chrome is a memory hog. Everybody knows that. But look at Edge. So Edge clearly needs quite a significant bit more RAM than Chrome does. So final note here on the comparison between the various browsers is, as you can see, the efficiency depends on what metric you look at. So if you're mostly interested in CPU efficiency, well, then go with the browser that is best there. If you're most interested in, let's say, limiting disk I/O or less memory demand, then look specifically at that. Okay, next comparison. Well, let's compare them for video size. Again, those are 4 different videos I played, but all encoded in 1080p, so basically same visual quality. There are some significant differences here. Here, I combined all these are averages for all the four browsers. Now, of course, there are huge differences, as you can see. Looking at all of it combined, this YouTube, of course, this Vimeo, and those two generally are much more efficient than the other two. So playing back video, YouTube needs about 450 something megabytes of RAM in your browser, as does Vimeo. But this Daily Motion crap, they don't know who accessed that site. I did for the first time for this test, and I was blown away by the shitty quality. But that is one of the most popular sites on the internet, apparently. So for the same thing, Daily Motion needs nearly twice as much RAM. And also look at the CPU utilization when playing back video. Something like 4%, YouTube and Vimeo, and nearly 3 times as much with the other two. Okay, now, second topic, let's look at the performance of web apps. Web apps these days are basically JavaScript apps, and when you're interested in web app performance, you need to look at JavaScript performance.
Okay.
Now, yeah, there's a question?
Going back to the video, how does HTML5 or Flash figure into that? Are those just delivery mechanisms?
Yes and no. Well, none of the video websites today use Flash anymore. That was all HTML5 video.
Okay.
And everything I talked about before, all that codec stuff, that is all about HTML5 video.
Okay.
Okay? Well, just take one after the other.
I know on Daily Motion there are quite a few ads. Do you incorporate ad blocking into testing?
No. For that, I deliberately just used default configurations of everything, no plugins, nothing.
Okay.
Did you test, the same websites with and without GPU to see if there was an impact on the CPU and how much that was?
No, this is a very broad topic. I know we could make tons of interesting comparisons. No, I didn't do that in this case, no.
Very good.
And it was the same video on those sites because you had a list before that showed the different videos on the sites that you referenced.
No, those were 4 different videos, but in the same resolution. The reason I chose 4 different videos is because, well, not the same wasn't available in all 4, but I didn't find any at least.
Yeah.
Okay, now JavaScript performance. Some of you may have known the term SunSpider. That is a very popular JavaScript benchmark. It has been around for a certain number of years now, and it's totally obsolete now. It doesn't reflect real web app performance anymore. It's just a synthetic benchmark that basically says nothing about your browser's performance. So don't use that or other obsolete benchmarks anymore. It's very difficult to come up with a good benchmark that realistically reflects browser performance with real web apps. One that seems to be pretty good is Speedometer. And what it does is it emulates basically a simple to-do list app that's running through a certain set of a certain workload, and it tests this. The same app is implemented in how many? I think 8 different, using 8 different APIs and popular frameworks. Those kind of JavaScript frameworks that are used on real-world websites today. So this seems to be some of the best benchmarks for browser JavaScript performance around today. Now what I did here, basically similar setup, same machine, same data collection mechanism and so on. In addition to the actual performance metrics, I also looked at the speedometer rating, because it's a benchmark. At the end it spits out a number and that tells you how good or how bad your machine is. That rating shows you how fast the browser is. And also, in addition to the rating, I looked at performance numbers like CPU utilization, RAM utilization, and that shows you how efficient the browser is. I see the difference, the results in a few seconds. Now, looking at the speedometer rating only, basically Chrome blows all of the competition away. They are not even close. Edge is basically half as fast, and you can forget IE and Firefox. So their JavaScript implementations are way behind apparently, at least according to this test. It could be that a different benchmark would give different results. Now, what I find a lot, even more interesting than the actual speed of the browser is the browser's efficiency. And we have here the CPU seconds that were utilized by the browser to run that benchmark. So that benchmark has a fixed workload. It is the same in any browser. And the less resources the browser requires to run that workload, the more efficient it is. And here we look at CPU, here we look at RAM, and here we look at disk I/O. And you can see that clearly Chrome not only is is the fastest one of the pack, but it's also, in terms of CPU utilization, by far the most efficient. So Edge needs approximately 3 times as many CPU resources to do the same thing, and IE probably 4 or 5 times as much. Looking at RAM consumption, well, we saw that before. Edge needs even more RAM than Chrome. That was in the video test. And this very different JavaScript test, it confirms that. So Chrome's RAM utilization relative to the others is pretty high. Edge is even worse. Firefox is not much better than Chrome, so those are pretty identical. And as before, in terms of RAM utilization at least, IE is very efficient here. Interesting. And as with the other video tests before, there's not a lot of disk I/O going on here, but Chrome does generate quite a lot, in terms of a difference here, quite a lot more disk I/O than the others.
It's because they're all that tracking stuff, they want to know everything you're doing.
Maybe. Okay. And the final topic I'm going to talk about in this session is the impact of ad blocking. There was a good question earlier. All of that was with the default stuff and not blocking ads. And yes, Dailymotion has a lot of them.
I flipped off my ad blocker and looked at it. Whoa.
Yeah, you go blind if you open that page. Now, there are several different ways to block ads. One way is to use a browser extension. The most popular one is certainly AdBlock Plus, which is available for all major browsers. Or uBlock, which is available for Chrome and Firefox. It's less popular, but we'll see some interesting differences between the two. Another way to block ads is using built-in functionality. So IE has the ability to filter content based on lists. The feature is called tracking protection, and you can select the list which is used by the same list that is used by the ad blockers. It's called Easy List, and you just point IE to that list, and you'll have an ad blocker. And for Firefox, that works too. The same thing works by changing the configuration, as shown on the slide. Now, there is some some shout out to Dan Allen. He worked with and for Login BSI, created some a very interesting white paper. I suggest you read that. It has some very good insights. And basically, he was testing, in his test, he automated 15 different popular sites and 6 tabs in IE only, and he ran the Login BSI product, and the BSI Max benchmark result basically that was coming out was with ad blocking, 99 users on that in that configuration, and without ad blocking, 75, so a significant difference. Now let's see what my tests show. So what did I do? Here's the test procedure. Basically, I started the browser, waited a little bit, and then opened seven different tabs. Here you can see the URLs that shows them more or less at random, trying to pick popular topic, popular stuff. I cycled a little bit through the tabs, then I waited for 5 minutes, so I just let it sit there, and then I closed the browser and took measurements. Now, impact of ad blocking in Chrome. So, the left is native Chrome without any plugins installed or extensions. This is Chrome Plus with AdBlock Plus, and this is Chrome with uBlock. So, interestingly, in this test at least, AdBlock Plus does not reduce CPU utilization at all. Going forward, looking at memory utilization, AdBlock Plus even significantly increases the memory that is required by the browser, which is not what you want. Well, it does block the ads, of course. That works. But resource utilization is increasing. But you could assume that if you have less stuff going on in your browser and less stuff being displayed, the utilization should be lower. But, well, the extension itself seems to be pretty inefficient. Now, uBlock, on the other hand, it does more or less the same. The result is more or less identical. Ads are not being displayed, but it actually significantly reduces your browser's utilization of both the CPU and RAM. RAM not as much, but still measurable. Here I've noted the number of hosts that are being accessed, which is quite interesting. With default configurations, all those ads, they are talking to dozens or sometimes even hundreds of different hosts who all track you. And you don't want that. So for privacy, the smaller this column, the better. And uBlock seems to be pretty efficient at reducing those people that can spy on you. Okay, so I walked through that. uBlock is much better. And the final measurements I took is, so that was Chrome. Let's take a look at IE and compare IE in the default configuration with IE with that EasyList tracking protection. And the results are pretty good. Dan got about 25% reduction in utilization by enabling this EasyList stuff. I got a little bit less, but still, it's nice. Here it's somewhere around 85 or so in the CPU utilization. Here, maybe 90% of what's being used without the ad blocking, and it also reduces the number of hosts that are being accessed significantly. So that is good. That is an easy thing. You can even deploy that by group policy. Dan has described it in his white paper how that works. Not very difficult. So sounds great. If you're using IE in your environment, if you're using Chrome, well, take a look at some of the others. Yes.
Does it automatically update the TTL file when you push it by policy, or it's something you have to do with a partial script and a bunch of GPPs?
Actually, I didn't really look at how it is done by group policy. I'm not sure. It's probably a registry setting, but I'm not sure.
Initially, James Rankin, one of the CTA, wrote an article about this, and I think it's you that wrote the partial script. but there's conflicting information now that you don't need to do it, it will update automatically itself at the next login or so, so I'm not quite sure.
Okay, well, I haven't tried that out. I didn't want to repeat what others already did, so I wanted to run some different tests. So I wasn't specifically looking at how to automate this or stuff like that. Sorry.
No problem.
Okay, there's another one.
You know, it always fascinates me that in spite of there being this huge history of web browsers, that people keep inventing new ones all the time. I've been playing around recently with one called Brave.
A browser? Brave?
Brave, yes.
Okay.
Brave.com, which in fact has an automatic built-in ad block functionality.
Okay, very nice. Yeah. I didn't know about that.
I've been playing around with it a little bit. It seems surprisingly efficient, just, you know, with no analytics to back that up. But these things come and go all the time. It's very, very interesting. I think my main point being that obviously there's a very strong interest in trying to optimize these things because, like it or not, people spend a huge amount of their time using web browsers, and you know, even small percentages of gains overall amount to huge amounts of time savings.
Oh yeah, absolutely, yeah. Okay.
Out of curiosity, did you try or look at the host span way of just doing things where you're just modifying the host file?
No. That is not an approach I would personally take because, well, modifying the host file is a little bit cumbersome. And so, no, I didn't look at that. Okay.
I know a few of the CTPs were in Remco's session on Thursday, and his information, now he didn't quantify how he was blocking ads, but his information seemed to indicate that ad blocking gave you tremendous improvements in CPU and memory compared to yours, which seemed to indicate not a whole lot was going on.
Yeah.
Well,
I
that could be
haven't seen
because
this
his tests
data.
were isolated to the specific websites versus, you know, the settings. They tested two different things. It's apples and oranges, but both are accurate and show a reduction. How much you get, maybe your mileage may vary.
It always depends
Oh,
a
okay.
great deal on what exactly you measure, what you try out. So I opened 7 different tabs, 7 different sites. If you look at just one site, it might be very
Remco
different.
did just one side,
Yeah.
he did a Dutch.
Yeah, he didn't really
Include
quantify.
BrianMadden.com, and those would change quite a bit. Yeah, and I run ad block on it all the time. I'm switching to uBlock though after this.
Ola, you just tell me when we need to cut off.
Just a few minutes, that's fine.
Okay, so just a few questions. Additional questions?
Another thing you have to look at is user behavior. I noticed with, first we rolled out 7.6, our default IE website was MSN. And the
Ooh, that's
yeah,
right.
the default behavior also was to group icons. So I had users that would have like 25 copies of MSN open because they would click on it, try and open a new one, and not use one of the ones, you know.
Hey, redundancy.
Background. So yeah, I mean, I had users that were using like 3 gigs of RAM and most of the CPU using their session.
You know, my homepage for Firefox is about Mozilla.
Okay.
So is this all done with just one tab? Is it?
No, with 7 different tabs open at the same concurrently at the same time. Okay.
So is IT still the fastest way to download Chrome?
I guess so. Or you can use Edge, it's also available in the operating system. So yeah, we looked at this, Easy List does help. And with that I'm done. Thank you very much.